I'm Paula Parreira and I'm from Porto, Portugal, and I work here at I3S. And today, within the scope of developing non-antibiotic anti-infective strategies, I'll present you my poster that is entitled The Trojan Horse Approach, Cholesterol-grafted biomaterials as a non-antibiotic approach for Helicobacter pylori infection. Helicobacter pylori infection is a public health issue. This gram-negative gastric pathogens infects the stomach of more than half of the worldwide population, which means around 4 billion people. It causes several gastric disorders, such as chronic gastritis, peptic ulcer, and is actually the etiological agent responsible for 90% of all gastric cancer cases, the fifth most common and the fifth deadliest. The available treatment is based on a complex combination of 2 to 3 wide-spectrum antibiotics together with other drugs. But the treatment effectiveness is hindered by high rates of antimicrobial resistance, as well as the severe side effects caused by this treatment, and among them is dysbiosis. So in this context of needing new strategies, biotechnology and nanotechnology can help to develop specific strategies to target key features of this pathogen. Our aim is to target a key feature of Helicobacter pylori, that it is cholesterol auxotrophy and positive chemotaxis. To survive, Helicobacter pylori must extract cholesterol from the gastric epithelial cells and incorporate it in its membrane. When doing this, the bacterium disrupts the lipid rafts, subverting the host immune system response. Also, by doing this, it improves its resistance to the antimicrobials. So we want to develop a strategy that uses cholesterol as a bait so that the bacteria can recognize it, and when trying to incorporate it, it will actually incorporate our biomaterial, a nanoparticle, leading to membrane disruption. And to validate this rationale, here I bring the proof of concept studies we developed. We started by developing 2D model surfaces grafted with different concentrations of cholesterol. By having these surfaces, we could control the cholesterol exposure, concentration, and molecular orientation. And we could check that H. pylori was able to specifically recognize and adhere to these surfaces in a concentration-dependent manner. And the optimum ratio was achieved in surfaces with 25% of cholesterol. Then we moved this knowledge to the 3D model surfaces. And we selected to use gold nanoparticles. Gold nanoparticles are biocompatible, they are easy to prepare and easy to functionalize, and also easy to characterize. So after having our cholesterol nanoparticles, we went to check its effect against H. pylori J99 strain, a highly pathogenic strain associated with poorer prognosis. And we set the minimum bactericidal concentration at 125 micrograms per milliliter. Then we wanted to know what was the mechanism of action behind this, if it was actually the bacteria trying to incorporate this biomaterial. And by performing transmission electron microscopy assays, we saw that after 2 hours, the nanoparticles begin to interact with the bacterial membrane, leading to its disruption and consequent bacterial death. We checked these nanoparticles' biocompatibility. So by checking their safety cytotoxic profile against the gastric adenocarcinoma cell line, and we also tested its hemocompatibility profile. And we saw that even using concentration 6 times higher, we had a safety profile. So no harm was done either to the cells, and non-hemolytic performance was seen. Then we wanted to know if these nanoparticles would interact negatively with bacteria representative from the gut microbiota. And we selected to use E. coli and Lactobacillus acidophilus. And we saw that these nanoparticles, even at concentrations 4 times higher, did not affect the bacteria representative of the gut microbiome, highlighting its gut microbiome-friendly nature. Overall, our proof of concept study supports the further development of biomaterials based on cholesterol grafted on its surface as a new strategy to target Helicobacter pylori infection. I'd like to finish by thanking the people involved in this work, as well as the funding agencies. And if you want to know more about our bioengineering strategies targeting gastric infection, please feel free to look up for us on LinkedIn or on our website. Thank you.